Still this button is always in the way. So just let's take a look at it. Okay, first of all, I'll look at the overall 3D geometry. Okay, right? Okay, nice looking. So we have some large floor plate at the lower floor, right? And also upper floor, it set back and drop. So I think you drop the wings, full wings. Later on, drop the wings at the different elevation. It's easy to delete. I always play around. So once you finish it, or 3D, just delete a couple of floor, one wing, second wing, third wing at the different elevation. It looks something cool, yeah, right? Otherwise, this looks kind of symmetric. You love symmetric building, do so, but it doesn't hurt you and anything is this is I'll show you. All right. So at least we know that geometry. Okay. And Control D. Okay, you set up the grid, 30 by 30 grid. Okay. So that you add the two beams, right? Beam is spaced at 10 feet on center. So just I'm gonna just go down and take a look at it. So I think you follow along my video. So column is so hit here you expand the math, right? So okay. So this is trial error. There is no such a shortcut. So you assume that this notch may end of day is really worth it, or you can just fill it. It's okay. It's up to you. But I think as it is, it's okay. So I'm just right click and just take a look at what thickness and concrete strength do you use. So name is one thing, but I'm gonna check just briefly, right? Slab 9 feet mat. What is the section properties? So 109, 108 inches. Mat type, you assign 6,000 psi, right? But also, while you're looking at it, you should be able to double check, make sure, because sometimes, in many cases, human make a lot of mistake, error. You assume that the name seems okay, but property in the number might be not right, right? So here I'm just checking, okay, weight per unit volume for concrete, 150. Mostly concrete strength, Young modulus is a big role, right? So you have this number. I think there are many ways to do this. You can type it or using built-in calculations, a calculator in here. But seems to me this is okay. So 4415 KSI. Okay, seems reasonable. So I'm just jump up the next floor. Okay, so maths, but you assign the source spring here, right? 480, and then I'm gonna move up. So column is placed at every intersection, 30 by 30 bay, concrete core wall. Okay, I'm gonna turn on the what sizes you're currently having it. This still uh, okay. So I'm looking at this the lower floor. Okay, need to turn on that moment release as well and release. I turn on this. Okay. I'm gonna turn off this. Just okay. So I'm looking at one lower floor, right? Seems like all moment released. I'm gonna click and see deck one, loading library 100, STL 20, construction library 20. But the deck one, you use deck one. Typically, I want you to come up with this name conventions. What, otherwise, you don't know what is that one you assign, right? Come up with always name convention, sign convention. If you, so here, okay, you assign 3-inch metal deck, right? Maybe 3 metal deck plus 4.5 concrete, right? You could do that too, concrete, and maybe C4, so 4,000 psi. Something it could be make. I think if you want, make it shorter. Metal deck, concrete, and concrete thickness and concrete strength, because sometimes the ETABS doesn't like all the some symbol. So okay, 3-inch plus point and a half, but should be normal weight concrete, right? This for 2-hour rate requirement. So 4,000 psi concrete should be normal weight concrete. So then go to check material 4,000, see 150 is normal weight concrete, right? So it should be consistent. What am I doing here? You're gonna do it in. I've been doing this entire my career. I think another 10 years, I'm gonna do the same thing. All right. There's no shortcut, but I know at least minimum. This is I need to set this. But here, just if you really kind of sick and tired of this, somehow come up with all these material properties and section properties commonly used and use as a template, right? So if it taps, you could create some template for general use. So based upon your project, right, high-rise building project, you could use it as a template. You don't have to recreate every time this, right? So something that you can think of. But anyway, since we are learning it, I'm just showing every single one you need to check it because you're gonna make mistake a lot because you're gonna keep doing same thing. You before you know it, you kind of screw up the unit, right? Inch versus feet easily, pound versus kip very easily, but you should be able to catch right away, right? Because I make a mistake because I thought this is a pump. I tried to assign the uniform area load, but I was actually still with the kip per foot. So when I assign and then I run it, I see the output. My reaction is totally outrageously so huge. Then I have to double check where did I make a mistake, and I found out corrected. Right? Those are QA/QC for you yourself. Don't just show this type of frustration to your supervisor. You should do your QA/QC at your level. That's why you're currently practicing now, right? Right? Because sometimes I'm sick and tired to see my young engineer, right? Bring it up. Hey, Simon, doesn't work. I don't know what's this. Okay, I can guide him first, supervise him 1 or 2 times, but you cannot keep doing the same mistake again. Because I'm explaining. Okay, if something wrong, why don't you ask yourself? You might have some better mistake somewhere, right? Why don't you go through this and find it? Otherwise, you're losing your credibilities. If you keep continuously make a mistake and you report to your boss your mistake, I'm not gonna trust you anymore. I'm having a very hard time. My PhD student, even sometimes a ridiculous mistake, I have to just review his all quality of work. Now I don't have feel confidence about his quality. Don't just yeah, okay. Don't do that. No matter where you go, you need to serious about it because this is career development. But you need to show, you need to know how you can control because there are a lot of routine tasks, right? Because of routine tasks. But if it is totally new, yeah, 1 or 2 times you can make a mistake. But I want you to still have some sense of the QA/QC procedure for you because the unit is always the case. So, okay, up to this floor, I'm just using my brain. I think you probably already designed this typical floor so that you end up with W16, right? So W16 for 30 feet span seems reasonable because we have a live load is pretty 100, quite significant. For girder, you could see that what kind of girder size? 24, right? 24, 18. It depends on your bending moment demand, right? Nothing new. This is something is a common sense. We already know it. First of all, I want you to just go through, okay, first design, okay, which one has those, okay, in filler beam has the same demands, right? Because they are on 10 feet on center and 30 feet span. So you most likely you need to come up with the same size. If you, sometimes ETAPs give you different size, that means you think everything is perfectly 10 feet, but you may be slightly off here there, right? Graphically, you may be draw it. That's why sometimes the E-types give you different size. It's similar but different size. Then you need to pay attention and check the what is the moment and shear that the E-types use it. So basically this is a kind of checking procedure validate. Then you could do it by yourself. So always curious and ask something wrong, something weird output. Ask yourself, check the unit and geometry, right? That's the bottom line. No matter what, you should do it entire. So this floor, just one, we just checked. I'm just giving the overall, okay, geometry, right? First column and beam and border and wall, you draw all this. Again, just think about it. It's gonna be same procedures. No matter any project you're working on, it's gonna be same, right? You need to define geometry, structural form geometry, but it's all coordinated with the architect. Set up the 30 feet spacing, right? That meaning there's a very meaningful. It's not just random. This is the office module, but this span length is some. I've been told tell you that maybe typical 40 45 feet is pretty common too. But since you have a geometry well set, 30, it's okay, right? No issue. So now you choose all the beam is span in this direction, right? So that plate you draw that one big plate and span in this direction, right? Should be all perpendicular to your series of beam. If you happen to draw it for this orientation is this direction, it's totally wrong, right? It's gonna fall down, right? Physically, just use a little bit of common sense now. It's nothing actually crazy. Just because this is kind of collocated metal deck should be sitting on top of these beams, right? So it seems like, but what about core? At this point, I think don't worry about it. But I mentioned it since these days high-rise building we use concrete as a shear wall system, right? Mostly this inside is will be concrete construction, right? Not everywhere, but majority majority of the high-rise building construction we use concrete. So this one, since concrete wall and beam since concrete guys kind of form up and pour the concrete, it's going to be concrete beam, right? So this is concrete wall and concrete beam. Obviously, we need another beam here because the elevator bank and opening and stair opening. Yeah, we do need some beams, but at this point, we just focus on composite pro framing beam. But I want you to aware of it. Don't forget when you present and this presentation to someone, okay, just mention it, right? High-rise building, we understand that two egress stairs should be there and elevators, but this is something that we are focusing on the structural design. So we didn't draw. You don't have to draw most like opening, right? But at least you agree, acknowledge that this core is all concrete construction, right? So I'm looking at this overall. Okay, for now, so, okay, I'm gonna move to upper floor. So I'm just increase this and see. Yeah, same dimension and spacing here. Okay, here, right? Same moment release, all girder and beam is the moment release. Here is one thing then I'm gonna add. Why do okay? You understand that the filler beam has a moment release, so simply support beam, right? So why do we need a shear connection of girder, right? Because at this moment we try to not to use part of a moment frame, girder and column uh, that's rigidity part as a part of our lateral system. Our core wall is much stiffer, right, than this contribution of girder and beam. If you happen to, I think you probably saw it at the downtown. There's a black building has huge gutters around. Window is very tiny. That is a moment frame. They don't have any this core wall. So the lack of lateral system, they're using higher perimeter column and beam as a moment frames. That's why they end up with a huge beam, steel beam. Got it? World Trade Center, which actually collapse one, they have their same system. The gutter is very huge. Well, column spacing is very closely spaced, less than 10 feet. So there is a series of column because they try to engage all parameter moment frame as part of a electric system because they didn't have any concrete core wall. They may have a few brace frame, but that's the point, right? Here, basically, we have a good, nice backbone. We intend to use the concrete core wall, shear wall as our backbone. Column and gutter is relatively minor. Even though you're using big gutter, your contribution is relatively smaller than this concrete wall. Concrete wall is very stiffer than steel. That means more economical, right? So remember that. So seems like you guys actually well the complete. Do you want me to run this model? Let's see. So I assume that gravity is done. Oh, lateral. Let's check the load cases. Dead load, okay. Self weight. So dead load again. Don't forget this is self weight modifier one. It taps always default one, including self weight automatically. It taps calculate the self weight of your structural element. But one thing that don't again, what you've been seeing this is structural element. You do not include any architectural element in your model, right? Sometimes you maybe think about there are a couple of reasons, but most of this the high-rise building or vertical building, we don't include any non-structural element, right? So even though this is not structural element, don't include it, but we include the weight of this, right? So that is part of our design load, but we don't model this. Okay, don't make a mistake at all. Think about it. What is a structural element, non-structural element? Just again, ask yourself what is a loaded bearing element, gravity load and also lateral load. Start with the gravity, right? If you look at the floor framing layout, your house, yes, this one is still. I'm kind of yeah. Here is a looks like concrete column. This one concrete column, concrete beam, but this is weird. Somehow looks. I don't know what did they use. It's a load bearing wall. Not. I'm kind of very suspicious of this building, but other building is very straightforward. So here, so okay, live road as composite dead load on construction live road win here. Now since New York City Building Code adopt SC 716, our ultimate wind speed is 115. Exposure B because it's something urban environments, right? So we assume so wind should be can be E types generate based upon your building footprint at the base as the base of the building and up to story 40. Uh, is that this one? This one. Oh, here. So I think something since we are using ETAPs, their wind load generation, something what you need to know is again diaphragm because you need to tell building width and depth is this much, right? Because the wind load calculation is based upon your basic wind speed and exposure and other parameters, but you need to somehow tell your model what is your building width, right? Height, part of wind tributary area. So here is typically the wind generation. You need to define the diaphragm, which include all the point nodes in each floor. This based upon your node, it helps calculate your building width, x and y, right? So this is diaphragm, and it's already find out. Okay, x direction is 94. No, yeah, y direction is 94. That's it's 154. So they already smartly find out the building width. This one saved a lot of effort too. You are lucky. You guys actually are lucky. 10, 20 years ago, I have to do it manually. I have to measure, assign something. This is a very relatively automatic kind of feature. So so I'm just one thing that ETAPS has here, because ASC7 has a total address a total 12 cases. The ETAPS generally, if you click here, include create all set, they automatically generate the win load total 12 cases like this, right? Total 12 cases. Maybe I'll show you that ASC7 what this guy means. The first one is you could guess it. Okay, one is blowing in extraction, so angle is 0. You see that angle 0? The second case set to 90. The wind is blowing y direction, right? So this is just somehow total 12 cases we need to consider, but you could see that set 1 angle equals 0 means wind is fully blown in x direction. 90 direction is wind is blowing in y direction, right? But third set 3 is case 2. The zero wind is blowing in x direction, but we need to consider 15% of eccentricity. Do you see that 0.15, right? E1 ratio. That is something cool. Kind of address that because there's some always eccentricities. So you're building full blown in x direction, but you need to apply the wind as with the 15% eccentricity. Y direction same, plus minus, and also combination x and y effect. You see, I think there is some diagram I will show you later. But this is something that you could just, this is kind of common sense. It's, you just see it, the diagram is easy to see it because the wind is blowing in any direction around the 360 degrees. But the building, because the wind doesn't mean always blow, so your center of the wind, centroid of the wind forces doesn't have to be always centroid. Somehow we need to consider some eccentric effect. So wind is a fully ultimate wind load cases we created here. S wind, Sy somehow, I guess you set it up another service wind load, right? Previously we always use a service wind load, and then later on we using 1.6 load factor. So previous version we have a 1.6 wind service wind, but now new version RC7, right? We're using ultimate wind load. So ultimate wind load means 1.0 times W, ultimate wind. So I put A plus B, B plus A eventually same, right? So I want you to aware of it. Why do we have a service wind and why do we have ultimate wind? Don't get confused. This is very important. Any mistake is going to be outrageous impact because we're talking about load factor 1.6. So at least principle of current era rapidity, we're using ultimate wind load, ultimate load, and reduction factor. So that is era rapidity method. Okay, seems like you guys said this one should be 90. Okay, this one's x direction, so you have a angle 0. Okay, so x direction, y direction, you set it up. Great. So the one thing I'm gonna check, seems you should already have it. This doesn't click. So I'm gonna turn on the diaphragm extent, right? So every floor nodes are tied with. Let me turn off this. So see the dashed line. Seems like every floor you have a diaphragm and tie all the nodes on same elevation. So I'm gonna run the model. I save in my desktop. Huh? Here. The graphically. Okay. This so you see all the nodes. So the baseline. This is showing diaphragm extent. That means so somehow you select all the nodes and assign diaphragm automatically type. ETAP is smart enough, right? You only define the floor to floor elevation, right? when you select all the nodes and assign diaphragm, they recognize it, right? Each discrete elevation, and they automatically tie the diaphragm. But if you happen to have a node between the floor, right? You somehow subdivide this column by 2, then they usually pick these nodes, right, and tie with the floor above, so that diaphragm is screwed up. So but typically we don't introduce the intermediate node between the floor, so usually okay. But if you happen to have a node, if using not this brace frame, sometimes we have different configuration, end up with a point nodes between the floor, you need to double check your diaphragm is that node, intermediate node, is included or not. So you need to disconnect that node. So here, so up to here is okay, right? Right? Now, what we've just finished is generating geometry. We just finished the up to here preprocessor, right? Input, generate a geometry, and also section or define the material section properties, assign the properties, assign the boundary condition. We define the load cases, define the load case, and assign the load case in diagram. This is the pre-process. Right now we run the analysis. Now analysis part is just complete, right? So this is something, the phase we need to bring our engineering judgment, right? So that we need to use our engineering judgment and validate your current model. Sometimes you make a lot of mistake, then you should be able to find where you make mistake. I kept make a mistake many times when I draw that. I thought I clicked this node, but sometimes I click a little bit off from this node, so continue to problem, right? If there is some problem, I think you should be able to catch by just first of all look at the deformation shape. So here I'm gonna use first of all yeah, this model. I'm gonna turn on this. So I'm gonna take a look at wind X direction using turn on, and then X direction contour. Wow, this scale factor is too much, but let me use a little bit. I turn on the contour, but turn off the contour. So first of all, each step see that volume, volume. So what you see, this building is moved globally. Do you see that? Sometimes you make a mistake, some column maybe discontinued, and beam and column is just dancing, right? You should be able to check connectivities, right? So now you don't see anything, it's more global building performance movement, right? By just checking the deformations, the displacements, right? So you could check X direction, Y direction. That's something that your validation, the procedures. So whether you make a mistake or not, you can just take a look at the displacement, X and Y. Also, if you want, just see that your displacement 5.6 inches. Sometimes if you made a mistake and somehow you need, yes, end up with what, 100 inches of feet, obviously you should know this. You made a mistake, right? So this is kind of common sense. So you are building engineering common sense by running all different type of building and exercise. You have to build a sense, structural sense. So up to here, X, Y direction, you could I'll just take a look at the floor. So usually faster, right? So wind 1. Yeah, obviously just we're checking wind 1 out of 12. structure. Right? It's common sense. Use common sense. Nothing actually. Now then, guess what? Win two. Okay, I'm gonna switch to win two. Oh, oh boy. What do you see now? Altitude is much different. Building stiffness. I exaggerate the deformations scale 100. So this scale is outrageous. So let me just adjust the this. Okay, yeah, 100. I'm gonna turn off. Okay. So y directions. Okay, makes sense. Y direction, right? Right. Now 3. What do you see now? Oh, this is always happening. This is always happening. Okay, here's another lesson learned. Right? I mean, this is really. I've been using this. It has 25 years. It kept happening like this. Abnormal. What did I do? Right? It's crashed. This software, I don't know, it's crashed. Maybe ETAPS related. But point is, you need to back up your model always. Good thing is when you run the analysis, you should have all the output in your local drive or server, right? But it crashed a lot, so I want you to always back up. So what I do, I'm gonna reopen that. This is ridiculous. This is still happening. I think this inheritance problem is not just only machines. But I think I see all output I have, so I'm gonna turn on the yeah, this doesn't click. So all right, now okay, I'm gonna just oh okay, here's this. So deflection, okay, 3. Do you see now? What do you see now? It's like when it's going X direction, man. What? You see some twisting. Torsion, get back. Because the load in X direction is offset 15%. So that in 3, it has, right? Generates the wind, from center of your 15% off. Here. You see that? Because this is all the load sum cases that based upon A67, the point. So total ETAPs generate 12 cases of drive this effect. The y direction, you can see that same thing, you can guess. Again, wow, this is the one. I have to stop it and go back and then redo it. This is really ridiculous. I maybe can videotape and send to ETAPS. This is happening 55 years. They didn't solve this. Ridiculous. Oh my gosh.